Welcome to clickmyproject.com. Our project title is Multi-Attribute SCADA-Specific Intrusion Detection System for Power Networks. Let's see the abstract. Cybersecurity has become a high priority in industrial automation. While attacking the multiples of system means vulnerability leads to get a high ubiquitous process can be easily removed by using the IDS framework. Access control processing mainly launched the anonymous attacks. In this context, a novel SCADA IDS with wireless and behavior-based SCADA protocol analysis is pre-processed and exemplified in order to detect known and unknown cipher attacks from the inside or outside the SCADA system. Finally, the proposed SCADA IDS is implemented and successfully validated to the series of realistic series performed in the SCADA specific test bed developed to replicate the cipher attacks against a substation LAN access control process in mainly launched the anonymous attacks. In this context, a novel SCADA IDS with weightless and behavior-based SCADA protocol analysis is proposed and exemplified in order to detect known and unknown cyber attacks from inside or outside a SCADA system. Finally, the proposed SCADA IDS implemented and successfully validated thought series of realistic scenarios performed in SCADA specific test bed developed to replicate cyber attacks against a substation LAN. LAN means local area network. Access control process is mainly thought of the anonymous attacks. Let's see the introduction. Securing the digital substation environment is just a part of a vendor and significant effort that is required to ensure the secure operation of advanced power system. There is a network-based NIDS and host-based HIDS. Intrusion the detection system. Some system may attempt to stop an intrusion attempt, but this is neither required nor expert to the monitoring the system. Intrusion detection and privacy system IDPS are primarily focused on identifying possible authenticate login information about them and reporting attempts. Secure for protecting the entire smart grid technological environment requires the consideration of main subsystem that makes up the smart grid. Let's see the accessing system. Most vulnerability has been started attacking in PLC, which had damaged the complete system as compromised attack not only from the externally, it also occurs in between the system access and unwanted action. So secure need to get enter the cyclic system architecture and advertisement of security has reached distributed management system and advanced maintaining the infrastructure for monitoring the wide area network. The process is under the smart grid technology. After the distributed IDS in wireless network has been proposed similar to previous process, but it was not concurring with superating concept but developing the statistical model research and introduced the anonymous detection approach to avoid the intrusion in the network. Let's see the proposed system. We are proposing SCADA IDS framework for detecting unwanted user on router by accessing the information about access control, whitelist and protocol based whitelist from the network. A secure and detection ID are all the major attributes going to use in our distinguishing the time and symbolic values lead to obtain the range of occurring intruder from the time characteristics association rule mining algorithm used to find the node occurs on network. Finding the occurrence lead to find the support and confidence for the complete node communication. Let's see the data flow diagram. Let's start our process, then go to the data inclusion, and then while list information extraction, then find the range estimation in higher low level, then go to the mining installation, then find the support part, and then go to the confidence, then they go for the min and max dependence, then find the detect and inserter in the data flow diagram. Let's see the demo of our project. And select the package information from our database. Click DARPA 1999. Let's see the database details. In the window, click the entry abstraction, then click the abstraction button to see the ID and duration services, and also see the attacker types. Click the filtration button to filter the attacker types, then click the multi-attribute classes, then click the binary attribute to see the attribute details, and to see the symbolic attribute. Let's see the symbolic attribute details, then continuous attribute. Click next button to find the linguistic terms. It's identify the ID and time under functionality, and click the values extraction to find the ID and low and middle high values from the database, and click the parameter values. Then go to the first form. Select the DARPA 1998. Click the entry abstraction. Click the abstraction button to view the database details, and click the filtration button to find the attacker types and details. So click the multi-abstraction classes to view the binary attribute and also find the symbolic attribute, then find the continuous attribute, then click the next button to find the linguistic terms. Identify the function low and middle functions, then click the value extraction to identify the low, middle and the high values. Click the parameter values, then click the rule extraction. Click the rule extraction button, then see the rules and details, and click the support to support the values and duration details, then click the confidentials. Click the update in values to enter the values. Minimum confidential value 1.0, minimum extrusion 3.0. Here also enter the same values. Click updating rules, and also click the classification. Click the test data. Select the values. Select the test.txt. Then click the match degree. That is calculated. Click OK. Then also find the classification to view the performance evaluation graphs, and also view the normal data and installation data. Thank you for listening.